This is our video number 5. Video number 5, PSAT review. We're looking at the calculator portion, and I believe we left off with problem number 16. Right? So if you remember, that was the summer job. Okay, so now we're to problem number 17. And here's the problem. It says the graph above shows the amount of protein supplied by 5 different food products labeled A through E as a percentage of their total weights. The cost is $2.20, $2.50 to $4, and $5 respectively. Which of the 5 supplies the most protein per dollar? Okay, so what we're looking for is the amount of protein per dollar. So if you look at the graph, the protein is on the left side. So A is 10, and then 15, then 20, 25, and 30. So they go up nicely. Those are percentages. And the costs are given in the problem. And because we want protein per dollar, we're just going to go down the line and calculate these and see which one gives us the best deal for the money. Okay, we do have our calculator handy. I'll get rid of that, clear that off. Okay, so the first guy, A, we have 10%, and we're dividing that by the cost, which is $2. And we can do this as percentages, or if you want to do it as a decimal, you're going to get the same answer either way. So I'll do 0.10. The second one, we have 0.15, 15%, and that's $2.20. So I'll just do 2.2, that's dollars. And then we have 20%, again, keep the decimal in the same spot. This is $2.50. And then we have 0.25%, and this is $4. And lastly, 30%, and $5. And we got to figure out which one gives us the most amount of protein for the money. So you just jump on the calculator and you start calculating these things. 0.1 divided by 2, that gives us 0.05. Let's see. So this one is 0.05. The next guy, we have 0.15 divided by 2.2. Okay, so that's 0.068. 0.068, so that's a better deal, more protein per dollar. Choice C, we have 0.2 divided by 250, and that gives us 0.08. So far so good. We're still going up, 0.08 protein per dollar. Choice D, we have 0.25 divided by 4, and now we've gone down a little bit. This is 0.625. Notice that's less than 0.08. And the last one, 0.3 divided by 5, and that's only 0.06. Okay, so the best deal for the money is choice C. That's the answer. Okay. Next problem. We're looking at a geometry problem here. Hopefully you've had some geometry back in middle school. This is talking about a quadrilateral. Let me get a little sketch going here. BC is parallel to AD, the top and bottom. So this is like a parallelogram. We also have A, B, and CD are the same. The technical name is an isosceles trapezoid, not that it much matters. And we have the height. Okay, the height is given as BE. So this is the height. And then they ask a scenario. What happens if the top and bottom are doubled? So twice as long. I'm trying to draw a sketch here. Twice as long, but the height is reduced. So we've got to make it sort of, I don't know if that's a good sketch or not. So here the height is 1/2 as much, but the bases are twice as much. And the question is, what's the area change? Well, maybe if you just sort of eyeball this, you could sort of make a reasonable guess. You should know the area of a rectangle is base times height. And if the base is twice as much, 2 times as much, and the height is only 1/2 as much, then the area is going to stay the same. Okay, so these two have the same area. The answer is C. doesn't matter whether it's a trapezoid or a rectangle, right? Because you're stretching one way and collapsing the other, the area stays the same. Okay, 19. Boyd grows only tomatoes and raspberries in his garden. Last year he grew 140 pounds of tomatoes and 60 pounds of raspberries, a bunch more tomatoes and raspberries. Tomatoes are pretty heavy. This year, by production, tomatoes went down a little bit, 20%, and the raspberries went down by 50%. By what percentage did the total yield by weight decline? Okay, so what we should probably do is figure out the total amount of last year. It was 140 pounds of tomatoes. We're going to make raspberries, or maybe they're blueberries. So here's our raspberries, and that was only 60 pounds. So the total last year was 200 pounds. But this year, the tomatoes went down. So sad. It says it went down by 20%. So a calculator is useful here. You had 140, and it went down by 20% of 140. It didn't lose a lot, 140. Okay, so let's try that again. 140, it went down by 20% of 140. There. So we're at 112. That's how much we had this year. And the blueberries or raspberries, they went down by 50%. Don't need my calculator for that. So 50%, let's say 60 pounds. We went down by half of 60. Well, half of 60, half of, my registration's not right here. Half of 60 is 30, so 30 pounds over here. Okay, so for this year, our total was 142 pounds. And so now the question is, how much did it drop? So what percentage did it drop? And it gives you the choices, 29, 30, 35, 70. You can see the amount it dropped, 200, take away 142. So it dropped 58 pounds. And how much of that is that compared to the original? And that's a drop of 29%. Choice A is the answer. Okay, number 20. 20 is another histogram here. Let's see, a frequency distribution of a list of randomly generated integers. That's between 0 and 10. What's the mean of the list of numbers? Okay, so the other problem had median. The mean is a fancy word for the average. And you know how to find averages. You have to add them up, and divide by the number in the list. So, well, first of all, we're going to have to figure out what numbers we've got here. The frequency is on the left. It looks like I'm just going to list the numbers down. We have a couple of zeros. No, we only have one zero. We have 1 0, we have 1 1, we have 1 2, we have 3 3s, we have 2 4s, don't have any 5s, we have a 6, a 7, and 8, don't have any 9s, have a 10. So the question is, what's the average of all those numbers? You go to the calculator and start adding these up. I probably would not key them all in. I would maybe add them up like this. We know these add to 3, we know these add to 9, there's 8. 7 and 6 is 13, and that's 18, and then maybe we can add these together in our head, or if you want, you could do these on the calculator. I'll just throw those middle numbers on the calculator here. So 3 plus 9 plus 8 plus 13 plus 18. Okay, so that's the total if we added all those numbers up. Now we had to count how many numbers we had. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So divide by 12, divided by 12, and there's your average. So 4.25, choice C. Okay, number 21 is talking about this graph. It says, what is the minimum value of the function? Minimum means the lowest in the xy plane for x's between -4 and -6. Okay, so here's the XY plane. Here's -4, here's -2, here's +4, and here's +6. And the graph of the function looks something like this. It goes up, sort of tops off here, and then it drops off like that. And what we're looking for is the lowest value between -4 and 6, and this is the lowest value. Okay, so the lowest value is -2, choice C. Okay, number 22, another scatter plot. So in 22, let's see, this is Hubble published the data shown. The graph plots velocities on the left against the distance from Earth on the bottom. And so velocity, that would be the speed, how fast they're going. Notice the units, it's kilometers per second. So some of these guys are not moving if they're near 0. They're like not moving relative to the Earth. And some of the ones that are further away, the distance is in megaparsecs. I'm not sure what that is. A megaparsec is 3.1 times 10 to the 19th kilometers. I don't know that that's important, frankly. But let's look at the data. And then they have one galaxy called Q, which is sort of pointed out. We have 3 questions on this. According to Hubble's data, how fast in meters per second is galaxy Q moving away from Earth? So you find galaxy Q, okay, right here, and here's the velocity over here, 500 kilometers per second. Well, if it's 500 kilometers per second, and you should know that there's 1,000 meters per kilometer, so you're just going to multiply these together, and sure enough, you're going to get 500 times 1,000, and that's the answer. Now, unfortunately, the choices don't have 500,000. They have it in scientific notation. The only one that makes sense, I think, is choice B. The calculator will convert these to scientific notation if you go over and choose that option and then just hit enter. And so you see 5, E5. The E means the exponent. So this is 5 times 10 to the 5th. Choice B. Okay, number 23. There are 4 galaxies shown in the graph at approximately 0.9 megaparsecs from Earth. Which of the following is closest to the range of velocities of these 4 galaxies in kilometers per second? Okay, so let's see. A little sketch might be useful. You'll have to refer to this picture and the problem at the same time. Here's 1.0, and this is 0.5, and they're saying the distance is 0.9. So what we're doing is we're looking in this area, and we're trying to find dots. They said there's 4 of them around there, and sure enough, I see one dot right here, which is close to 0 in velocity, and then there's another dot right above that that seems to be, I don't know, around 200 or so kilometers per second, and then there's another dot right up here, which is actually right on this line at 500 kilometers per second, and then there's one above that right about here, which is somewhere between 5 and 1,000, making a guess, maybe 600 or 650, 700, somewhere around there. Okay, and the task is, what's the range of these guys? You know, the difference in speed, basically, the range in the speeds. So it's this number minus this number. The only one that's close is choice D. I mean, even if we had said this was 650, right, instead of 700, the range there would be 650. The only one that's close to being right is choice D. Okay, number 24. Based on the model, what's the model? Remember, if you go back and read the problem, they use the word model right here. Okay, so this idea of velocity is 500 times d. That's the model that's being used. Velocity is 500 times d. And the question is, according to that model, what is the velocity in kilometers per second of a galaxy that's 15 megaparsecs? Well, if you look at the chart, 15 is way off the chart. You know, the biggest number in the chart is only 2.5 megaparsecs. But if you read the problem, it does say assume that the relationship is valid for larger distances. So all we have to do is go to our calculator, I suppose. Maybe you can do this in your head. 500 times 15. Okay. So, and I'm back in scientific notation. Let me put it back in normal mode. Okay, so 500 times 15 is 7,500 kilometers per second, choice A. Okay, number 25. Let's see what's going on there. Janice puts a fence around her rectangular garden. The garden has length that's 9 feet, less than 3 times its width. What is the perimeter of Janice's fence if the area of her garden is 5,670 square feet? And you have all these choices. These are perimeters. Okay. Well, I would guess a sketch sort of makes sense. So we have this rectangular garden. We don't know the width. We don't know the length either. But we do know the length is 9 feet less than 3 times the width. Okay, so this is our length, and it's 9 feet less than 3 times however wide it is. However wide it is. Okay, we also know that the area is 5670. The area is 5670, and our task is to figure out what's the perimeter. Well, this is a system of equations. Maybe you saw this in Algebra 1. Certainly in Algebra 2. The area of a rectangle is always length times width, and so the area of our garden is going to be 3w minus 9 times w, and that works out fairly nicely as 3w squared minus 9w. That's our area, but they told us how much it was. So 5,670 is the area, 3w squared minus 9w. So we subtract off, and we get 3w squared minus 9w minus 5,670. This is the equation that gives us the relationship between w, right, the possible widths of the garden. Now, how do you solve something like that? Well, your calculator solves equations pretty easily. If you go and you type that in, I'm going to use x's instead of w's. So it's 3x squared minus 9x, and minus 9x, minus 9x, and then minus 5,670. This will be a parabola. Here's the graph. I'm going to look in the standard windows for starters. I don't see it yet. This parabola is off to the right quite a ways. Let me change my window around. So my biggest x, I'll go up to maybe 100. And now you see the parabola, or at least you see part of it coming down. That's going to be our answer for w. So whatever number that is. Now again, it's sort of hard to see. The x scale is 1. Let me change that to 10. Okay, so now all these tick marks are 10. So 10, 20, 30, 40. It looks about 45. We can find that pretty accurately if you do second calc 0. The answer is somewhere between 40, and 50, right? And if I guess, it comes out to 45. Okay, so W is 45. That's what our calculator tells us. This much is 45. And then the length is 3 times that, take away 9. So we can use our calculator for that. 3 times 45 is that, take away 9 is that. The length is 126. 126 is the length. And lastly, we need the perimeter, and you know how to find perimeter. You take your length, you multiply that times 2. There's your 2 tops and bottoms. And then to that, you're going to add 45 plus 45 is 90. Okay, so the perimeter is 342. The answer is A. Okay, 26. 26 is a very specific problem. If you don't know trig, you're just going to have to guess here. They have angle A, they have the right angle C, and angle B. And then the sides are labeled little a, little b, and that's it. And the question is, which of the following is equal to b over a? And the choices involve sines and tangents. Well, if you know right angle trigonometry, the sine of this angle is always the opposite side. Sine of capital A will be the opposite side divided by the hypotenuse. And here they didn't even label a hypotenuse, so it would be A over question mark, or whatever that is. Okay. The sine of B is going to be sort of the same deal. It's going to be the opposite side, which is B, over the hypotenuse, which they didn't tell us. The tangent of A is going to be the opposite side, which is A, over the adjacent side, which is B. And that's not what we want yet. Remember, we're looking for this. The tangent of B is the opposite side, which is side B, next to the adjacent side, which is A. And that's the one we want. The choice is D. I should probably make a mention here. Remember, there is no penalty for wrong answers. If you have no clue how to do one of these things, you've never seen trig before, and SIN looks like something in religion class, you just have to make a guess. Don't leave an answer blank. At least put something down. So go eeny, meeny, miny, mo. As the time gets close to the end, remember for this particular section we had 45 minutes, I believe. Keep an eye on the clock. When you get close to the end, make sure you have no empty circles. Everything needs to be marked, even if you're guessing. That is a change on this year's SAT. Okay, 27. We're getting close to the end here. We have y is less than or equal to x, and 2y is bigger than 3x plus 2. And they have the picture. We're going to do this one on the calculator. You can actually graph things like this on the calculator. Let's see, y is less than or equal to negative x. Now, if I just look at it in the standard window, there's the line y equals negative x, but we have to be less than. Less than means below, and you can do that by changing the graphing style. This is hitting enter. That's above. That would be below. So here's the line and everything below it. That's the first equation. For the second equation, let's see, we've got y is, well, we don't have y, we have 2y. So let's divide by 2. 1.5x plus 1. So I'll enter that in, 1.5x plus 1. But for this one, it says we're supposed to be bigger than. So I have to go above that. And again, let me just go over to my graphing style. Let's see, hit enter. That's bold. That's above. So I'll hit graph. And there we are. Where these guys overlap is the right answer. That's section R. Section R, according to the picture, this region right here. Okay? So choice A is the answer. If you've never done graphing, again, just make sure you answer something there. Don't leave it blank. Okay, 28, 29, 30, and 31 are the grid ends. No choices are given. Let's work these problems and see how we can go about getting those. XY plane above shows one of the 2 points of intersection of a graph of a linear function, that's the line, and a quadratic function, that's the parabola. The shown point of intersection has coordinates v and w, that's labeled, but we don't know what they are. If the vertex of the graph of the quadratic is at 419, vertex is where it turns around, the high point, what is the value of v? Okay, so a couple things you should know about parabolas. Parabolas have a lot of symmetry in them. So for this particular parabola, we know that the high spot is at 419, and I'm looking at, here's my x-coordinate, which is 4. We also have this line zipping along, and the line zips along like this. This is point V and W. We're trying to figure out what V is. And we know that this point is on the line. This is the order pair 2, -1. Now, what that means is because this is symmetric, there would be another line going this way that would hit right down here. Let's see, this is 2. This would be 2 more, so this would be 6. -1. Boy, this is a sort of a poor looking question. It looks like that is right on the axis, but obviously it's not. It does say 2, -1. So this point is like right down here, 2, -1. Okay, and so this one is going to come down again, be below, just right there. And what I'm claiming is now this point is going to be lined up with that. Now, these guys are going to be the same distance apart. Okay, so yeah, this has got to be the number 6. So think going 2 that way, 2 that way, 2 that way, 2 that way. This is the number 6. V is 6. Okay. What is the value of V? Okay. Number 29. In a college archaeology class, 78 students are going to a dig site to find and study artifacts. Okay. The dig site has been divided into 24 sections, and each section will be studied by a group of either 2 or 4 students. How many of the sections will be studied by a group of 2 students? Okay, so typically I suppose we have, let's say we have this site and it's divvied up into 24 sections, so maybe 4 times 6. So here's 24 boxes. This is 4. This is 6 times 4 is 24. So we have these little grids. There's 78 students total. And let's see, each section will be studied by a group of either 2 or 4 students. How many of the sections will be studied by a group of 4? Well, let's see. Could they all be 4? All 4? No, that wouldn't make sense because we have 24 sections and each one had 4 students. Let's see. We'll try that. 24 times 4. That would require 96 students. We don't have that many. So let's figure out how many groups of 4 we could put in there. So we'll take 78 and divide that by 4. Okay, so that looks like 19.5 boxes. So this would be 4, 4, 4, 4, 4, 4. There's 6. There's 12. There's 18. There's 19. And then 2s would go 2, 2, 2, 2, 2. Okay, so let's see if that sort of makes sense. We've got 19 times 4. 19 times 4. Well, that's 76, but now that doesn't work because we have 10 students that we'd have to get there. So we can't have 19. Let's take those 4 students and divvy them up. So we have 2 and 2. Let's see. So now we have 4 times, what's that, 17. 4 times 17. 4 times 17 boxes. Okay, that's 68. And do we have 10 boxes left? Let's see. 1, 2, 3, 4, 5, 6, 7. Nope, not there yet. So let's take these 4 students and divvy those up into 2 boxes. And let's see if that works. Okay, so now we have 12, 13, 14, 15 times 4. Okay, so that's 60. And then 2, 4, 6, 8, 10, 12, 14, 16, 18. Good. So that looks like we do have, we have 9 boxes with 2 students in it. And the rest are going to have 4. So a little bit of trial and error there. It looks like the number of boxes with 2 students has to be equal to 9. Okay, 9. Number 30. Okay, number 30. See if we can find this. Hang on. There we go. 30 and 31. So these are the last 2 questions. They have the same equations. Let's look at these. An arrow is launched upward with an initial speed of 100 meters per second. The equations above describe excuse me, the constant acceleration motion of the arrow, where v sub 0, that's that little 0 in the subscript, is the initial speed of the arrow. That was 100 meters per second. V is the speed of the arrow as it's moving through the air. I would hope that you would know that would be slowing down when it goes up and then speeding up when it comes down. H is the height of the arrow above the ground. T is the time elapsed since the arrow was projected upward. And G is the acceleration due to gravity, which is given as 9.8 meters per second squared. Okay, so just writing these equations down, we have V is equal to 100 minus, now remember G was 9.8 and T, okay? Height is 100 times T minus 1/2 times 9.8 times T squared, and V squared is 100 squared, right, minus 2 times 9.8 times H. So this is just putting the numbers that they gave us into the problem, and I'm going to clean up this 0.5 times 9.8. That works out to be 4.9. So instead of 1/2 of that, let me just write 4.9. So 4.9. And for the second one, it said 2 times G. So 2 times 9.8. And that works out to be 19.6. And I'll put that right here. Okay, so that just makes it clean up a little bit easier. 19.6. Those are our three equations that describe this arrow. Let's see what they're asking. Okay, so the first question is, what's the maximum height from the ground the arrow rises? We're going to do that to the nearest meter. Do we have an equation that has height? Yep, sure enough, this is our height equation, and we want to make the maximum there. I'm going to do that on the calculator. So get rid of all this stuff. And again, this says H and T, but on the calculator, we have to use Y and X. So 100X minus 4.9X squared. And here it is in the standard window. I don't see much going on there. Let me zoom out a little bit. Zoom out. Okay, so I start to see something happening there. And let me just sort of tweak this. How high do you think it's going to go? This says it's only going 40 meters up. Let's change that, I don't know, up to 400. Maybe that's way too high. That's almost half a mile or half a kilometer. But let's see if that helps a little bit. Okay, so sure enough, we see this parabola, and it is even higher than 400, so go figure. Maybe it goes up to 600 meters, more than half a kilometer. Yep, there it is. And our task is to figure out how high it goes. The calculator does do that for us. It's under second trace. You go down to maximum, and what you need is some number to the left. It says 0. We can punch that in. And then some number to the right. Let me put in 6. Oops, that's not to the right. This second arrow has to be to the right of the high spot. So we'll try this again. We'll do maximum. Left bound is 0. Right bound, we'll put in 15. There we are. Okay, and it says the maximum is 510 meters. So we put down 510, and we're supposed to do it to the nearest meter. Okay, and the last question on the test is, how long will it take for the arrow to reach its maximum height to the nearest tenth of a second? Okay, so now we have our height given here. We know that the height is equal to 510. I'm going to go ahead and write a new equation. 510.204, and that's going to be equal to 100T minus 4.9T squared. And the question is, what's the time that it takes to reach that to the nearest tenth of a second? Well, this parabola that we got graphed here on the calculator actually gives us the information. It says when T is equal to 10.204, then the height is 510.204. So sure enough, this X value, which is really the time, remember we used this equation, and I used X here and here, and this was my y. The height we got, that was that, and we're just asking what's the time. And the time is the x value. It's right there on the calculator. So let me get rid of this equation. We don't really need it. We've got time is equal to 10.2 to the nearest tenth of a second. Okay, now if you look at the answer sheet, and maybe we can load this up a little bit so we can see it a little bit better. These calculator problems, the hard ones, these last few were hard problems. In fact, a lot of these calculator problems are hard. H stands for hard. So if you didn't understand these, don't feel too bad. Put something down. Remember, there's no penalty for wrong answers. So put something down. Check your answers as you go. If you're practicing with this, obviously the answers are not going to be on the test on Wednesday. Good luck. I hope this was useful. And we'll see you in class Monday, Tuesday. And for the sophomores and freshmen, we'll see you Wednesday.